Now next problem is, under blocked rotor condition, the frequency of rotor currents in a 50 Hz 3-phase induction motor is option A very low, option B very high, option C 50 Hz and option D about 50 Hz. Okay, so before solving this problem, now we'll read this question carefully. So question is from which topic? So this question is from induction motor, right? So the question belongs to induction motor. So under blocked rotor condition, the frequency of rotor current in a 50 Hz 3-phase induction motor. So this problem belongs to induction motor. This point is clear. So basically we have 3-phase induction motor, and this 3-phase induction motor is operating on 50 Hz supply system. This point is clear. Now under blocked rotor condition, so here in this problem, the main point is this: under blocked rotor condition. So here the problem is saying that under blocked rotor condition, the frequency of rotor current we need to find. Okay, so now if we have to solve this problem, so our basic concepts and regarding the working of induction motor we have to clear. Okay, so if we'll go in the working of 3-phase induction motor, as I told you in the courses, right? So basically we have two main part. Okay, one is stationary, second one is what? That is the revolving part. Okay, clear? So the revolving part is the rotor. The revolving part is what? The part which is rotating is what? Rotor, right? So here is saying that under blocked rotor condition. So basically in 3-phase induction motor, if we'll go, so basically we have, you see here, so basically we have two things. One is the stator and second one is what? The rotor. Second one is what? Rotor. Stator is a part which remains stationary and rotor is a part which is rotating. Okay, so as the induction motor, we know that induction motor will operate and give a mechanical energy to run some mechanical load, and then mechanical load will be connected to this 3-phase induction motor via the shaft, right? So it means that, and shaft will be connected with the rotor, so it means that the rotor is going to rotate. This point is clear. So now in this question is saying that the rotating element is what? Blocked. Here we have the under blocked rotor condition. So now if the rotor is blocked, then what will happen in this 3-phase induction motor? So again, by the working of induction motor, we know that we had two kind of rotating system here. Clear? One is the rotating speed of the RMF and second is the rotating speed of the rotor, and as we know, the rotating speed of the RMF will be how much? Is synchronous speed, and the speed of the rotor, basically we are dealing with the term NR, the rotor speed, right? Here is saying that the rotor is blocked, and if the rotor is blocked, it means that there is no rotating mechanism here. So because of no rotation of the rotor, so the speed of the rotor will be what? This will be equal to what? 0. Clear? As per the question mentioned here, under blocked rotor condition, we have blocked this rotor to rotate via some mechanism, and if this rotor is blocked via some mechanism to rotate, it means its speed is what? Is going to become 0. So NR is become equal to 0. So saying that under this condition, frequency of the rotor current is. Now consider, if we'll consider the second mechanism where the rotor is what? Rotating. Rotor is what? Rotating. So in this condition, if we need to find the relationship of the frequency which is developed in the rotor with the supply frequency, then we can say the Fr equal to what? Slip into frequency, supply frequency. Right? Right? So we can say this condition when rotor is in the rotation mode. So we can say the frequency developed in the rotor will be equal to the slip times of the supply frequency. Slip time of the supply frequency. Clear? But now, because on this condition if we'll go, so slip we can define it is what? It is the difference ns minus nr upon nr. If I'm not taking the percentage, I'm just saying about the slip. So ns minus nr by nr I can say here. And because, sorry, this will be the ns minus nr by ns. Now as per this condition, because nr is going to become 0 under the block rotor condition, so we can say what will be the value of slip is here. This become what? This become 1. This become 1 now. So now if we put this slip value here, so we can say the rotor frequency is what? This will be equivalent to the supply frequency now. So if supply frequency given in the question is how much? Is given 50 Hertz. So we can say rotor frequency is how much? Is 50 Hertz. This will be 50 Hertz. Okay. So answer for this particular problem will be the option C. Not about the 50 Hertz. No. This will not be our answer. About 50 Hertz. About 50 Hertz means just saying that about, but it is fixed that the rotor frequency will be equal to the supply frequency. There is no doubt on that. So that's why we'll take the absolute value, which is the 50 Hertz. Clear? So the important thing regarding this problem, that the working of three-phase induction motor and these things has to be very clear. Then we can solve this kind of problem with very ease. Right? So now if I'll ask you that, now if I assume that this rotor will not be blocked and this rotor is what? This rotor will be on the rotation mode. Then what will be then what will be the rotor frequency? Then on that condition, if the rotor speed is not equal to 0, in that condition definitely the rotor frequency will be less than the supply frequency. Very important concept as per the working of three-phase induction motor.